Welcome back. Today we're going to be talking about subtracting like terms. Now, kind of a refresher for your memory, terms, these are either going to be numbers, variables, or numbers being multiplied by variables, or variables being multiplied by numbers. A numeric term is basically a number, numeral number, like 7, 8, 9, 1 half. Um, an algebraic term, this is going to be a term that includes a variable like 5x, 3x, 7x, 1 half y. Those would be the type of terms we're going to be working with. So let's just go ahead and jump right into this and try some of these problems out. Let's say we have, for number 1, we have 0.9y minus 0.4y. Now in this case, all we're going to have to do is we're going to subtract, since they are like terms. These are terms that have the same variable attached to it, the same algebraic terms with the same variable. We're going to go ahead and we can subtract the decimals. We'd have 0.9 minus 0.4, which would get us 0.5, and then since it's attached to the y, it'd be 0.5y. So again, if we have 0.9y minus 0.4y, you're just going to subtract the decimals. You get 0.5, and it's y. Okay? Let's go ahead and try another one. Now, if you are a little bit confused in how we did the subtraction of these terms, go back and take a look at the adding like terms, and you'll see we have a kind of a visual with a bar modeling that you can view that maybe that will help you. But we're going to get right into the problems over here. All right, let's try another one. Let's say now we have 1.4m, and we're going to subtract m. Now, it's kind of important that you realize for a problem like this, the identity property. The identity property basically tells you that any number or variable times 1 will get you itself. For example, 1 times 4 equals 4. 1 times 8 gets you 8. If you have 1 times m, that gets you m. So in this case, we really have 1.4m minus 1m. And for you, it may be a little bit easier to think of it in terms of 1.4m minus 1m. That way you know what you're subtracting. So if we're subtracting 1.4 minus 1, we're going to be left with 0.4, and then it's just going to be m. 0.4m. All right. Now, sometimes you're going to be dealing with fractions with our terms. So we're going to go ahead and try one of these problems with some fractions. We'll start off with fractions with like denominators, and then we'll move into fractions with unlike denominators. Kind of move our way up. Okay, for number 3, let's have 3/4 x minus 1/4 x. Okay, in this problem, again, all we're going to do is we're going to subtract our fractions. So if we take 3/4 and we take 1/4 away, we are left with 2/4. But we know that that is equal to 1 half. So I'm going to go ahead and simplify that. So now I have 1 half, and we're dealing with x's. So we have 1 half x, and that's as simplified as we can make that problem. All right. We've tried one now with the like denominators. Let's try one that has unlike denominators. See how that works for you. So we have for number 4, 3/5 n minus 1/3 n. Okay, much like the other problem, we're going to have to do a subtraction of fractions problem. So why don't we go ahead and do 3/5 and 1/3. Find a common denominator. Well, you can get a common denominator by, well, first of all, you can multiply the denominators, and in this case, 5 times 3 gets us 15. That, in this case, is the least common denominator. If that wasn't the case, you could start listing out their multiples until you have the first multiple they have in common. Either way you do it, it will work just fine as long as you simplify at the very end. You'll be fine, even if you're not working with least common denominators, you can simplify that at the end. So just find a common denominator as your first priority. So in this case, we decided that we're going to use 15 for both of these fractions. Now, I have to multiply 5 by 3 to get 15. Therefore, I'm going to multiply 3 by 3. That way, our fractions are equivalent. So 3 times 3 is 9. And then 3 times 5 gets me 15. Therefore, I'm going to multiply 1 times 5, and that gets me 5/15. Okay, now I can go ahead and begin my subtraction. 9/15 minus 5/15 is going to get me 4/15. And it's going to be n. So now I have 4/15 n. Okay, hopefully this makes sense. This is your basic style of subtracting like terms. Now, we're going to go one step further. At this time, I'm going to kind of shift this up a little bit. At this time, let's go ahead and give ourselves a rectangle. We're going to say our rectangle, the measurements for this rectangle are 3 centimeters and 2.5 x centimeters. And the directions are simply to find the area of the rectangle. Okay, now when you're doing this, I would definitely start off by writing your formula for area of a rectangle, since that's what we're looking for. So area of a rectangle is A equals, I like using base times height since we're dealing with right angles. You may have learned length times width. Either one is fine. Again, I like using base times height. So I'm going to do base times height. Again, you can call it the height because there's a right angle. You have to have a right angle for it to be a height. But we're going to go ahead and do base times height equals area. Again, it does not matter since we have all 4 right angles. It doesn't matter what you call the base and the height. I'm going to call the height 3 and the base 2.5x. Again, it really wouldn't matter which one you call because I can maneuver the rectangle however I like, and it will be the same area regardless. So I have 2.5x for the base, and I have 3 for the height. Now I'm just going to have to multiply. Now, when you're doing this, if it makes sense to you, you could think of this as I have 2.5x, and I have 3 groups of them. Oops. I have 2.5x, and I have 3 groups of them. I was thinking 3 groups, and I wrote that down. So I have 3 groups of 2.5, and if I was to add these together, I would have 15... carry my 1, 7.5x. I could do it that way. However, multiplying would be much easier. I'm just trying to show you how this works. We can just multiply 2.5 by 3 and get 7.5. And then it's x. And then we need to make sure we label. It would be centimeters squared. And this is how we're going to find the area of a rectangle when we are dealing with algebraic terms. Let's throw all this together. I'm going to put this up at the top so we can finish off over here. Okay. Well, thank you for joining me. I hope this was helpful. You guys have a fantastic day.